Okay.
Yes. So this is chapter 13.2, question 33. So there's a volleyball. It's hit when it's 1.2 meter above the ground and 3.7 meter from a 2 meter high net. It leaves the point of impact with an initial velocity of 11 meter per second and at an angle 27 degree. So, and slid by the opposing team untouched. So the first question, we have to find the vector equation. So how to find the vector equation? There's a formula for vector equation, which is S equal to V naught T plus half acceleration T squared. So we divide into two parts. First, we find the x first, which is the distance for x. So it's V naught cos theta T plus half. So this one, the x direction don't have the acceleration, so that's why it's 0 T squared. So it's V naught cos theta T equal to, so the V naught is 11 cos, the angle is 27 degree T. So the second part is Sy equal to V naught sin theta T plus half of acceleration T squared equal to V naught sin theta T plus half. This is the y direction. The volleyball fly to the y direction and drop down, so that's why this is the gravity, which is negative T squared, negative GT squared. So the V naught is 11 again, sine 27 degree T plus half negative 9.8 T squared. So we get 11 sine 27 degree T plus, oh no, it's minus, sorry, minus 4.9 T squared. Okay, so the second part of the question is, we have to find how high does the volleyball go and when does it reach maximum height. So the height also have a formula, which is V naught sin theta square over 2g. So the V naught is 11 sine, the angle is 27 degree squared over 2 9.8. So 11 sine 27 degree squared over 19.6, and so after calculation, which is 1.27 meter. So we have to plus 1.2 meter because it's above the ground. So the final answer is 2.47 meters. Sorry.
For not realizing this, but in the first part of the question, we got it wrong. We got up to 11 sine 27 t minus 4.9 t squared. This is all correct. But since the volleyball is 1.2 meters above the ground, we have to add that into the vector equation. So basically, it'll just become 1.2 plus with 11 sine 27 degrees t minus 4.9 t squared. Moving on to question part C. They want you to find the range and the flight time of the volleyball. So the range meaning how far does the volleyball travel. So to find the range, first of all, since we know, we'll get the time first. So since we know distance of y equals to 1.2 plus 11 sine 27 degrees t minus 4.9 t squared. Alright, so once we got this, since t is the same for both in x and y, so we'll just isolate t. We'll find t using the formula minus b plus minus square root of b squared minus 4ac over 2a. Now I prefer to shift this over, so minus 4.9 t squared plus 11 sine 27 degrees t plus with 1.2. Alright, so minus b would be negative 11 sine 27 degrees t plus or minus square root of 11 sine 27 degrees. Oh wait, the t does not come into the equation. Minus negative 4.9, which is a, and 1.2, which is c. So equals to, oh wait, I forgot, divided by negative 9.8, which is 2a. So I just have to calculate this. So 4.99 negative plus minus square root of 4.99 squared plus with 4.99 negative plus minus square root of 4.99 squared plus with 4.9 times 1.2 equals to 5.88. Where times this by 4, so just give me a second. And you'll get 1.22 seconds. So this is the amount of time taken for it to reach. Now to get the range is really simple. We'll take the equation distance of x equals to ut plus half at squared, where u is the initial velocity of x, v naught x. So that's 11 cos 27 degrees times with the time, which is 1.22, plus with half, since acceleration is 0, so, and time is 1.22, but in the end this will become 0, so it'll just end up as 11 cos 27 times with 1.22. So that would equal to 11.96 meters. Now part E of the question asks for if the net were raised to 2.5 meters, will it change things? Well, definitely it would, because the overall height we got for the maximum height which the volleyball could travel is 2.47 meters. So since it can't pass the net, then it will just hit the net and fall down, logically, of course. So in the end, it will change things because the volleyball would hit the net and fall down, basically.